All right, we are beginning Unit 4. Today we're going to be talking about minimizing surface area. Now, throughout Unit 4, especially the warm-ups, we're going to start reviewing. You got your midterm coming up soon, so just make sure that you're reviewing what you have covered in Units 1, 2, and 3, because those are going to show up soon on your midterm. All right, the following is a piecewise function. We talked about piecewise function in the first unit. Represents Kieran traveling in miles from school, okay, to his house. How long did Kieran stay at Noah's house? Now, by the way, it kind of like is a little hard to read some of these, but also it's missing some things. This should be hours right here, and this is the distance from school. All right, so here we go. Um, or no, this distance from his house. Here we go. Okay, from Kieran's house. All right. Now, how long did Kieran stay at Noah's house? So right here, he left school and he got to Noah's house here. And then he's not moving. He's staying at Noah's house from here to here. This is from the X value of 0.5 to 2.5. So from 0.5 to 2.5, how many hours was that? 2 hours. All right. Now, how long did it take Kieran to get home from the library? All right. So right here is where he arrived at the library. Well, he stayed at the library and he left here. So from here to here is how long it took him to get home. Well, notice that X value went from 3.5 to 3.75. So if I subtract that, 3.75 minus 3.5, I end up with 0.25. So 1/4 of an hour. Now, what is a fourth of an hour? Well, an hour is 60 minutes. So if I divide it by 4, it says 15 minutes if they want to get particular about hours and minutes here. All right. Now, how far is Noah's house? Now, this is talking about distance this time. The first two talked about hours. So how far is Noah's house? Noah's house right here from school. Well, here we left school and we traveled to Noah's house. So it went from 3 miles from being from Kieran's house to 2 miles. So in between here, this is a difference of, we say 3 minus 2, which is 1. So Noah's house is 1 mile from the school. All right. So remember our piecewise functions, be able to read it, especially if it's kind of like a word problem. Now, in unit 2, we started doing a lot of factoring. Okay. The reason is we're going to hit it here. So we got to make sure that we remember how to factor. All right. Now, this was one of those quick factorings when there's nothing out in front right here. We can say X and X, and we say the factors of 6 that add to -5, -2, and -3. Okay. Now, for those of you who struggle with factoring and like using Desmos, we can do that. Not all the time is Desmos helpful. So using some of the tricks and stuff that we talk about on how to factor are going to be very useful. So here, notice it where it hits the x-axis. So if 2 is a root, then x minus 2 is a factor. If 3 is a root, then x minus 3 is a factor. Okay, so let's look at number 5. So number 5, we can do, now if there's something out in front, we can do the first times the last, which is going to give me -30. And we think of what are the factors of -30 that add to 13? Start playing around with it. All right, it's actually -15 and 2. All right, add to -13. Okay, so here we go. We rewrite the first, we rewrite the last. And then here, we take the -15 and put an X with it. We take the 2 and we put an X with it. And now what we're going to do is we're going to group it right here. Okay, the first thing that comes out of this group is 3X. The first thing, and we're going to be left with an X here minus, and we take a 3X out of this, I'm left with 5. Now out of this one, now that was a plus, so out of here, I take out a +2. All right, so when I do that, that's X minus 5. All right, so the two GCFs we pull out, 3X plus 2, and then X minus 5. All right, now that is how that factors right there. Now you ask, can we use Desmos? We can, but you have to be really careful on like this one, and I'll show you why in just a second. All right, so here we go. Again, we look at this right here. Now, one of the things we could do, we see this -5 right here. So when we see the -5, let me move this over a little bit. If we see it crosses that -5 right here, oh, I messed up, or did I mess up? I did mess up because look here. I was supposed to do +13, not -13. All right, so if that's the case, that is a -2 and a +15. You guys make these mistakes all the time as well. All right, so let me back up. Here is +3x, and we're going to be left with x plus 3. All right, here, because that is negative this time, I do need to pull out a -2, and that turns to an x plus 5. So this is x plus 5 and 3x minus 2. I actually saw I did it wrong because I did it in Desmos, because I saw right here, this is a -5, so the factor should be x plus 5, and I had an x minus 5 down here. So we always make those mistakes too, and double checking is always a great thing. All right, now for this other one. Now, what you could do is remember when we did synthetic division and we divided, and in the box you would put -5, or maybe you did long division. You could do that if you couldn't figure out how to get that. Okay, another thing you can do is this right here. Now, unfortunately, with the North Carolina Desmos, it rounds it to 3 decimal places. So this is a little misleading. This is actually 0.66666 repeating. Now, here's the thing. You got to know how to write that as a fraction. All right, if you know how to write that as a fraction, we could say x minus, and that's 2/3. Okay, and then we had x plus 5. Okay, and that's a 3 right there. And what you can do is take that denominator and put it out in front of that x. So we get 3x minus 2. Whoops, you didn't see me do that. Hold on, let me back it up. So I did x minus 2/3 right there. And then the 3 can go out in front of the x like that to get the 3x minus 2. Okay, that's one of your hardest factorings. All right, and then 6, what do you recognize that as? A perfect square. A perfect square, so the square root of x squared is x and x. The square root of 4 is 2 and 2, and one's a plus, one's a minus. It doesn't matter which one's which. All right, now if you want to graph this one, no problem, because x squared minus 4, and you can see if -2 is a root, x plus 2 should be a factor. If 2 is a root, then x minus 2 should be a factor. You can also do this right here and make sure that it's the same thing. All right, as long as these graphs are the same, guess what? You factored it correctly. All right, so that's another check. But that's one thing we're going to have to use in Unit 4 is factoring, so don't forget that. All right, now let's move on, and I want you to go to page 145 in your workbook. All right, so here we go. And we'll come back to our other page in just a second. All right, Interstate 40 spans across the continental U.S. Okay, we're on page 145. From Wilmington, North Carolina on the East Coast to Los Angeles, California on the West Coast. The total distance is 2,590 miles. At what average speed, or miles per hour, would you need to travel if you wanted to drive the full length, the interstate, in 48 hours? Well, pay attention to this, miles per hour. You're going to put your miles over the hours, because this is miles, and you want to do it in 48 hours. So our speed, when I go and do this, is going to be that right there. So let's round it to 3 decimal places, 53.958 miles per hour. All right. Now let's look at number 2. The total driving time from Wilmington, North Carolina to Los Angeles, California on Interstate 40 is reported as approximately 38 hours. What is the average speed? So again, it's the same thing. This time we're dividing by 38 hours instead of 48. Okay, so what do you think is going to happen to our speed this time? All right, let's see. Okay, it actually got faster. So if you said faster, you're correct. So 68.158 miles per hour. All right, now let's write an equation for the average speed as a function of the driving time. So if you notice the speed each time, we took our distance, which is this right here, and we divide it by the time, t. All right, we wrote the speed as a function of time. So let's go graph this equation right here. And let's relate speed and time together. So I'm going to do 2590 divided by x. All right, I'm going to put x in here. Now, obviously, I don't see anything. Now, I can zoom out, and I do start to see something. Do you see this right here? Now, we really only want to pay attention to the positive. We don't want to deal with the negative because if you notice our t, we're not going to have negative hours. So things like this, like right here at 13.6 hours, it's going to be 190 miles per hour. Do you think we're really going to go that fast? But as I keep going, I can see this. If I end up going 65 hours, I'm driving at a speed of 39.846. And as my hours go up, so here, let's describe the relationship. As time increases, speed decreases. Or if you want to say it the other way around, as time, because we can see from numbers 1 and 2, as time decreased, speed increases. All right. So we can have a relationship between that right there. And you guys looked at things like this last year in math too. All right. I'm not going to worry about graphing it here. We just saw it on Desmos. All right. So let's move on. Okay, flip over a page and we want to look at number 40 or on page 146. All right. So we've got these 4 hollow cylinders that have the same volume. Which cylinder needs the least material to build? I don't know, just take a guess. Some people may say A because it's taller. Some people may say B because it's thicker, or maybe some people might say D. I would say D is smaller, so it's not going to need as much material. But what information, and so this is just a guess. So what information would be useful to determine which cylinder takes the least material to build? All right. If you thought of the word surface area, okay, to know the surface area of each of these cylinders, okay, and think about a present and if you were wrapping it up, all right, how much wrapping paper do I need to cover each one of these? That's what we're looking at here, okay. All right, so move on to page 147, okay, and let's look at this first activity right here. Now, there are many cylinders with volume 452 centimeters cubed. Let R represent the radius, H represent the height of these cylinders. And we just got out of like volume and stuff last unit with geometry. Complete the table round to the nearest tenth of a height. Okay, tenth of a centimeter for our height. Okay, first off, what do you remember a volume of a cylinder is? Pi r squared h. Okay, so here, if I have, and if you notice, all of these are 452. Okay, and I want to solve for my height. Now, as long as, and if you notice, the radius keeps changing. Okay, so here, if I actually divide by pi r squared each time, I'm going to be left with whatever the height is. Okay, so let's think about this for a second. So 452, okay, I'm going to put it in fraction mode. So 452 divided by pi, and in this case, it's going to be 1 squared. Make sure you square your radius. So this is 143.9. All right, let's do it again. Okay, 452 divided by pi, 2 squared. All right, so 35 we'll just say 36.0. I'm just going to round these to 1 decimal place. All right, now 452 divided by pi, and then 3 squared. Okay, so that's going to be 16.0. All right, do you see what we're doing here? Well, one thing we could do instead is we could actually take Desmos because we kind of have a formula that we're doing. We're doing 452 divided by pi. You can just type in pi for pi. And then now it's r squared. We're going to say x squared though. Okay. Now you could find this on here. We can do, okay, when x equals 4. All right, what is it? So 8.992, so that's 9.0. All right, we can change this, x equals 5. This way, we don't have to kind of keep typing it in. All right, we can just keep changing this value. So 5 point, oops, I wrote the wrong thing, 5.8. All right, keep going. Let's change this when our radius is 6. All right, so 4.0. All right. What happens when our radius is 7? All right, it's 2.9. Okay, change it to 8. And our radius, our height is going to be 2.2. All right, let's change it to 9. Okay, 1.8. Okay, and then if we change it to 10, all right, which is over here, okay, it's going to be 1.4. Okay, what happened as our radius increased? What happened to our height? It decreased. Now, we had a formula that we wrote at the top, and we kept doing 452 over pi r squared. Okay, and that's what the formula that you see right here that we put in Desmos. All right. So using a graphing technology to plot the points from the table on the coordinate plane, what do you notice about the graph? We actually have already graphed it. And we can put in each of these points. And by the way, if you want to put in points, you can. All right. So 1 and 143.9. All right. And then we put 2 and 36. All right. 3 and 16. All right. 4 and 9. Oops, put the wrong one. Okay, and you can see the points right there. Now you see them pop them up. All right, we do 5 and 5.8, 6 and 4, 7 and 2.9, 8 and 2.2, all right, 9 and 1.8, and 10 and 1.4. Okay, so right here, let's look at it. And that's like that same graph that we just had in there just a second ago on the right-hand side in the first quadrant. So what do you notice about the graph? As the radius increases, the height decreases. All right, so those are inversely, we call it inversely related to one another. Inversely means as one goes up, the other one goes down. As one goes down, the other one goes up. All right, so let's look at this right here. Let's look at the surface area. Now, if you want to, you could just go and take this one and just put a column here, surface area, so you don't have to recopy this. If you want to recopy it, you can. I just went ahead and recopied it, although it only gave us up to 8 here. All right, now I just flipped over one page. I'm on page 148. Activity 2. Okay, calculating surface area. There are many cylinders with volume 452. Okay, they can be a certain height with a certain radius and so forth that we were just looking at. Let R represent the radius of these cylinders, H represent the height, and S is the surface area. Use the table to explore how the value of R affects the surface area. Round to the nearest tenth. Okay, now first off, what is surface area of the cylinder? All right, surface area we'll call as S is 2 pi r squared because there's 2 circles on either end of the cylinder plus 2 pi RH. That's how we figure it out. Okay, so here we can go figure out this right here. And I'm going to quickly plug this in. So 2 pi r is 1 squared plus 2 pi r h. So 143.9. All right, so this is 910.43. Okay, so let's go to 2 pi times 2 squared. All right, plus 2 pi times 2, and then that's times 16. So 226.19. All right. Now, if you want to, if you're using one of these calculators, if you do second and the enter button down at the bottom, it actually puts whatever we wrote. Notice all we're doing is we're changing the radius, say to 3. Okay. And then this time, this changes to 9. All right. Actually, this is actually the same thing, 226.19. Okay, so if I do second enter again, the height now is 5.8. Okay, this was for, I'm sorry, I did this wrong. Hold on one second. I did this wrong. Oops. Okay, 2 pi, I think I got the wrong thing here. I do because I didn't put 36 right here. So 2 pi times 2 squared plus 2 pi times 2 times 36. So let me back it up. So it's not the same thing. All right, let me fix this. This is going to be 16 and then 3 and 3. All right, this one's 358.14. All right, so let's do this again. Second enter. So that's 4. This is 4, and we change the height to 9. All right, so 326.72. All right, do it again. So 5.8 when our radius is 5. All right. What are you noticing this time? All right, as I do this, is it always going down? All right, if you actually looked, it went down, but then somewhere right here, it starts to go back up. Do you see that right there? Okay, as the radius and height changed. So this time, the surface area does different things. It's not going to be the same depending on the radius and the height. It actually is different. Okay, so here, um, okay. And what we can do is we can actually graph in Desmos the radius and the surface area. That's what they want us to do. So remember how we did these points right here? Okay, the radius is 1, and then this is 9. Okay, the radius is 2, 477.5. All right, the more times you do this, the faster you get at it. And I'm using my keyboard right here. And I'll zoom out in just a second so you can see some of this. Like that. Okay, so if I zoom out, because these are actually fairly big numbers, we start to see it right here. All right, and these all just kind of keep changing right there. It's kind of weird. All right, on what's happening. All right. Okay. Now, let's write an equation for S as a function of R when the volume of the cylinder is 452. Now, remember this. So up there, I had written this. All right. However, a lot of times we can't have two variables in there. Do you remember from the other page what we said H was? H, and if I flip over, I can recall when the volume was 452, it looked like that. So that's what I'm going to write right here. So it's times 452 divided by pi r squared. Well, guess what? I can actually reduce this. I'm going to keep the first part as 2 pi r squared plus, all right, here I can multiply 2 times 452 and I get 904. Okay, notice how there's a pi down here. But then also, do you see how this r can cancel with one of those r's and we're left with an r down there? So we can rewrite the surface area formula like this. All right. So we can write it in there if we would like. All right. Now I'm going to stop this video and then I'm going to do a second video. So come back to part 2 to finish this lesson.